Hi. Okay, log functions. This is not Unit 9. This is Unit 12. Unit 12, Day 1. Go us. Okay. What's happening? So, a logarithm is another way to write exponents. So, logarithms and exponentials are inverses of each other. Okay, so if we have log base b of a equals x, you can change that to an exponent. That's b to the x equals a. And here's this little graphic here that shows you, like, to write a log in exponential form, you can draw this weird little L thing. And to write a log in exponential form, I think I said that opposite, but we could do that thing. Make a little e. Okay, so let's get into these. So let's write each of the following in exponential form. The base is always the base. Whatever it equals is the exponent, and then the number inside is your answer. So we can just draw a little e right here because we're changing it to an exponent, so we're going to draw an e. So that's going to be 3 squared equals 9, which is true, so we're good. Okay, this will be 6 cubed equals 216, which is also true, so we're good. 7 to the 0 power equals 1. Awesome, we're good there. And then you can do the next 3, and there's those answers so you can check them. Okay? Let's go backwards now. So let's go from putting an exponential into a logarithm. That should be an equal sign on this first one. So we can draw that little L. It's a kind of weird L. It almost looks like a golf club. But that's going to be log base 14 of 196 equals 2. Because you hit the 14 first, then the 196, then the 2. Next one, log base 3 of 81 equals 4. Next one, log base 12 of 12 equals 1. You can do the rest of those. Those are the answers there. Okay? Now, a common logarithm. That's a logarithm with the base of 10. So if you ever see log base 10 of x, that can be written as just log of x. And then it's just assumed that the base is 10. Okay? So let's evaluate these using our knowledge of exponents. So I'm just going to set this equal to x. Now, change that to an exponent. That's 7 to the x power equals 49. Well, 7 to what power will give me 49? If you don't know right off your head, then just start checking in your calculator. But 7 squared equals 49, which means x equals 2. Okay, let's do the same thing on b. So I'm going to set that equal to x. Then I'm going to have 3 to the x power, maybe. 3 to the x power equals 27. Well, 3 cubed equals 27, so then x equals 3. Okay, for c, remember that if there isn't a base, you assume it's a 10. So that's going to be 10 to the x power equals 100. 10 squared equals 100, so x equals 2. Then for this last one, set it equal to x, change it to a logarithm, or to an exponential, sorry. So 12 to the x power equals 1. Anything to the 0 power equals 1. You could take 1,942, raise it to the 0 power, it will equal 1. You could take 1,000,000, raise it to the 0 power, it will equal 1 every single time. So then x equals 0. Okay? Save those next 4. You can do them in class. Now, we have different properties that go along with logarithms. So logarithms, we went through how to change them from a log to an exponential and yada yada. Now there's different properties. So say you have log base b of m times n. Well, that's the same thing as log base b of m plus log base b of n. So let you use that property to condense these. So we have log base 2 of 7 plus log base 2 of 4. That's the same thing as log base 2 of 7 times 4, which is log base 2 of 28 when you multiply those out. Okay, b, log 25 plus log of 4. That's log of 25 times 4, which is log of 100. Okay, if we have log 4 of 2x plus log 4 of 4x squared, that's log 4 of 2x times 4x squared, which is log 4 of 8x cubed. Okay, now if we're expanding these, I know that 6 is the same thing as 2 times 3. So that's log of 2 times 3, which is log of 2 plus log of 3. Okay, I know that 45 is the same as 5 times 9. So that's going to be log base 7 of 5 plus log base 7 of 9. Okay, see, we have log base 2 of 5 times x. That's going to be log base 2 of 5 plus log base 2 of x. Multiplication goes with addition. So that means that division probably goes with subtraction. Okay, so log base b of m over n is the same thing as log base b of m minus log base b of n. So if we have log base 3 of 24 minus log base 3 of 8, that's just dividing 24 by 8, which is 3. Okay, b, that's 15 divided by 15, which is 1. So log base 2 of 1. C, that's log base 4 of x to the 9th divided by x squared, which is log base 4 of x to the 7th. Okay, now if we expand these using the quotient property, I know that 4 is the same thing as 8 divided by 2, so that's log base 8 of 8 minus log base 8 of 2. For b, that's log base 5 of 1 minus log base 5 of 3. For c, that's log of m minus log of 7. Cool? Now the power property. This is kind of the weird one that doesn't make as much sense as the other two. So multiplication goes with division, or multiplication goes with addition. Division goes with subtraction. The power property doesn't really go with anything. It's just kind of a silly property that we have. But if you have log base b of m to the nth power, you can move that n to the front so it becomes multiplication. So that's n times log base b of m. So power goes with multiplication, I guess. Okay, so if we condense these, I can just move that 5 up, so that's log base 4 of 2 to the 5th power. B, that'd be log base 2 of x to the 7th power. Just move that 7 so it becomes a power. C, that would be log base 8 of 1/3. Now, if we're going to expand these, I'm going to move it back. So that's going to be 7 times log base 2 of 8. On B, that's going to be 3 times x minus 1 times log of 4, which you can multiply that 3 in, so that's 3x minus 3 times the log of 4. And then for C, if you ever have a square root, that is the same thing as a 1/2 power. So square root and 1/2 are the same thing. Power of 1/2 is the same thing. Move it to the front, so we have 1/2 times the log base 7 of W. Cool? Okay, one last thing on this video, natural logarithms. So we talked about how log was a base 10. Well, a natural logarithm has a base of e. And e is an irrational number with a value of 2.71828 blah, 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 blah. And e is kind of like pi. It pops up in the world a lot. So it's used to describe real-world scenarios with logs and exponentials. Sorry, words are really hard. So exponential functions with a base e are called natural base exponential functions. So that would be like e to the x. Logarithm functions with a base e are called natural logarithms. And that would be like log base e of x, which is the same thing as ln of x. Okay, so if you ever see ln of x, that's just log base e of x. Okay? So let's get into this. So we're going to write each equation in logarithmic form. So I'm just going to draw my little L, and I get log base e of 24 equals x, which is ln of 24 equals x. Okay, for b, that would be log base e of 9 equals x. Well, log base e is ln, so that's ln of x equals 9. For c, that's log base e of 72 equals x plus 5. which would be ln of 72 equals x plus 5. Then if we're going to write this in exponential form, that's going to be log e of x equals 58. Draw my little e, change it to an exponent, so that's going to be e to the 58 power equals x. The next one would be e to the x power equals 6. And the last one would be e to the 32nd power equals x minus 9. Okay, so it's basically the same as the other logarithms, it just has a base of e. And then we can simplify these using the same exact properties. Addition goes with multiplication, and then subtraction goes with division. I want you to try and do these ones on your own. See if you can figure them out. The one you're probably going to have trouble with is E and F. See if you can figure them out. If not, that's okay. Ask about them in class. Okay? Remember to take the quiz, and I will see you guys later.